Today we're going to take a look at the snake challenge from Topcoder. Now, what I've done is using Ruby and a library from Ruby, I created a 2D game that represents the old-fashioned snake game that we used to play on our phones. Now, there's a couple of things. To set up this game, we have to have Ruby 2D. Now, Ruby 2D has its own requirements as well. In order to set up Ruby 2D, we have to have Simple 2D loaded and built onto the local machine. Now, Simple 2D is just a library that we can get from Homebrew. We do this by typing in our bash shell brew tap simple2d/tap, then brew install simple2d. Once we have Simple 2D installed, it's a simple bundle install to load the gem file, and we get our dependencies built in. And then finally, we can use the Ruby 2D methods. Now, again, if you are testing or running this on a Linux box, there is in the notes the methods to set up the Simple 2D. Just go ahead and do that. And once you have that all set up, you can go ahead and run the program. Again, just go ahead and bundle install from the gem file to get Ruby 2D set up. And then we can go ahead and run our game. Now, a quick demo of the game before we go through the code. We'll go ahead and show you what happens. Now, it builds using Ruby 2D, it builds the window that we're going to be using, sets up the title. I titled this Ruby Snake, and I set up a scoreboard, and the score is going to be kept for every apple that we eat. Now, as per the instructions, there are two apple sizes that are required for this game. The first is the large apple, which we see here, and this will give my snake 2 points, or my player 2 points, when I eat the apple. Notice that my snake started off with 2 parts, a head and one section tail, and it now has 2 sections when we ate that larger apple. Now we eat the next large apple. We now have 5 sections because we added 2, and my score is 4. See if we can get a small apple to load here. And there's the small apple. Now notice this apple is about half the size of the larger apple, and both of the apples do say TC in them for Topcoder. When you eat a smaller apple, you get 1 point. Again, the large apple says TC. Now I created each of the apples using GIMP and just created a simple pixel art. Same thing for the head of the snake. I just created a simple 20 by 20 pixel art for the snake head. I just wanted to not use a dot for the snake head to show the difference between the head and the tail parts. All right. Now, the next thing that we need to test, obviously, is the collision. If it runs into a wall, then what happens is we get the final score of the game, which for this game was 7. Notice the snake head. We can actually see in detail now the apple has disappeared from the screen, and there are 1, 2, 3, 4, 5, 6, 7, 8. Let's see. 1, 2, 3, 4, 5, 6, 7, 8 snake parts. Again, we started with 1 snake part on the tail, and then we added 7 for each of the points that we got. This game can be restarted simply by pressing R, and we can go ahead and start the game again. Now, we need to check the collision on the snake body, so if the snake runs into itself, we need to make sure that the collision is detected. Now, one thing that the snake cannot do is it cannot turn upon itself, because that would result in an automatic collision. So I've built into the snake class, or the movement abilities, that when it moves, it checks to see which direction the snake is currently traveling and disallows the directional change in or opposite the direction that it's currently traveling. Okay, so I think my snake's long enough to test a collision, and we do get a collision. Final score is 12, and again, R to restart. So that is my snake game in a nutshell. I did use this the Ruby 2D to build my game window, and this quickly allows me to actually change the game color if I wanted to. I could just run the game again real quick, and I could change the game color. I could also change the dot for the snake tail. It's a simple string code shift to change the color. And I think I actually like lime here better than the green itself. You can kind of see the apple leaf when this thing is at lime rather than green. So I did code a leaf onto the apple as well. All right, so that said, that is the Ruby snake game in its entirety. Now, notice I didn't build this as a web app. I built this as a simple free-running app on your computer, so you don't have to be connected to the internet to play this game. And I'm not using the Chrome browser or any of the browser tools to actually run this. It's simply Ruby 2D. I wanted something a little bit different than the JavaScript apps that I saw, and since we've been building most of our coding challenges in Ruby, I kind of wanted to stick to Ruby because that's what I'm familiar with currently. So again, that is the game by itself. So it does run. Again, it uses Ruby 2D. I have created the snake file in a separate library, or the snake class in the libraries file, but the game itself is part of the main directory, so you should just be able to run game.rb to run this game. And there's a couple of things that we can go ahead and do with Ruby 2D. I showed you the setting the background. I can change the title if I wanted to, but what we can more importantly do is change the frame rate of this game. So if I wanted to make it faster, I could change the FPS cap to 20, say. If I wanted to make it slower, I'd change it to 5 or 1 even. I could change the window size, so I could do 320 and 320 rather than 640. I kind of want to keep it at measure increments of 20 pixels because that is the size of my snake parts and apples. So again, the grid size is set to 20. Okay, so going over the code, we have our main game class, creates an accessor to Apple, and I can read whether or not the game is finished and the score. This is just for building that into the game window. Initialize my score to 0, set my apple to nil because I haven't drawn an apple yet. My apple X is going to be a random grid from the width, the Y is going to be a random grid for the height, and finished is going to be false because the game is just starting. Then I run select apple. Now select apple is just a method that's built into game, and again this is to choose between the two apples. Select apple sets a variable called apples, and then creates a hash called big apple and little apple, or a hash that uses big apple and little apple as keys. Big apple is an array of the image itself from the image file, and the points that apple is going to be worth. Small apple is smallapple.png, and it's worth 1 point. And then to choose an apple and to set the apple as the apple variable, or the class instance, I'm going to take a sample, a random sample, from the apples.keys, and so that will grab my apple and points for me. Okay, then we draw the apple onto the window. That's basically all the game is. It's a snake that runs and it finds an apple on a field. So really all I need to do is draw the apple into the game board because the snake draws itself using the snake class. Now again, that apple is an image, so I have to load the image as a new image. And the file name is what we set for apple at index 0. Then x and y are going to be the grids that we set up here, and those are the random grids to start off with. And then I go ahead and draw the text for the score. And the score has two messages, which we built into a private method called text message. If the game is finished, it says game over. Else, it just registers the score. Okay, so that is the drawn board. Again, it's just an apple and the score. That's it. Then the snake, or then we have a class called does the snake hit the apple, or snake hit apple ? And then checks the x and y. So if apple x equals the x of the snake's head and the apple y equals the y of the snake's head, then it's hit the apple. Okay, so if I want to record the hit, then the next method is record hit. I have to increment the score by the point of the apple, which was the apple class instance at index 1. I have to select a new apple because that's the apple that's going to be drawn, and then I have to set the random coordinates for that new apple, which I'm going to do. I'm going to check something afterward. Then I have to check whether or not the game is finished when we're running the game, and if finished equals true, then the game freezes or stops and places that game over mark. The apple disappears, and we can press R to restart the game. Then we have our simple game loop. So if the program name is named file, or the name of the file, then I create a new snake, which we'll talk about the snake class in a minute, and I create a new game. And then I use Ruby2D to start that game loop. And again, the game loop is running at the frames per second that we set. And then it updates doing the following things. So it's going to clear the screen. Then it's going to move the snake, and we'll talk about the move method in a minute, unless the game is finished. If the game is finished, the game freezes, the apple disappears. Then we draw the snake, and we'll go through the snake draw method in a minute, and we draw the game. So the snake is drawn onto the window, the apple is drawn onto the window, and then things start moving. Or, I'm sorry, the apple and the score are drawn onto the window, and then the snake starts moving. Okay, and this happens basically until the game is finished. While the game is running, it checks does the snake hit the apple or snake hit apple ? At snake x and snake y, and again those are just the coordinates of the head of the snake. And then if the snake hits the apple, I set a value called previous score, and that's going to be equal to the current game score. Then I'm going to record the hit, which will increment the game score, and then until the previous score equals the game score, I'm going to grow my snake, which we'll talk about the grow method in a minute. As I grow my snake, the previous score is going to increment by 1 until the snake is the same size as until the number of snake tail pieces have been added to the snake to correctly set the length of the snake tail. And remember, we're using 2 apple sizes, so we have to increment the snake more than 1 sometimes. So that's why I set up this method here. The game is finished if there is a collision. Now that collision can either be with the walls or with the snake itself. And again, we'll go over the collision in a moment. Then I had to set the movements of this, so I had to set key presses. Again, built into Ruby2D is a method called key down, or key down is an event, and once it's going to check whether or not the key down event was up, down, left, or right. And if it is, I can change I check to see if I can change the direction, which we'll talk about in a minute with the snake class. And if I can change the direction, I'm going to change the snake direction to the direction of the key hit. Else, if the game is over, I am allowed the opportunity to press R to start the game, to restart the game, and then I get a new snake and a new game set up. Once all that is done, I go ahead and am showing this constantly, so the update is showing. All right, so that is the game instance. Now let's go ahead and talk about the snake. Now again, this is just the player class, so this is the snake. And I'm going to simply create an attribute writer called direction, because this allows me to change the direction of the snake at any instance by a key press. I initialize my snake at 5.3 and 5.4. And then that's where the snake starts. Now you pretty much start the snake anywhere. You just have to be careful about starting it on the edges because there is edge collision, and if it runs into a wall, the game will automatically be over. So somewhere right in the middle of the game field allows the snake some movement, and there you go. Now, drawing the snake, draws circles, draws the snake head and circles for the tail, and circles for the tail parts. Well, tail, singular. So the snake head is just an image, and that's that 20 by 20 image that I made look different than the dots so that you could recognize the snake head from the body. And if we wanted to take a look at that real fast, that snake head is simply in the image file, and there you go. There you go, that's the snake head. So there we go. So that's a simple snake head. It's not a dot, but it kind of looks snake-ish, and that's just what I have built for it. So put the snake head, or draw the snake head, and then I'm going to, from position 0 up to the snake head, because the snake head is the last position in the snake position array. Then for each of those positions up to the head, I'm just going to draw a dot. So it's a circle that is going to be placed at position, whatever that position is, at 0, 1. And then it's going to increase that position by the grid size. Again, we've got to remember that we're dealing with grids here, plus grid divided by 2. Now the reason I do this is because when it builds a circle, it's building the circle with a radius, and if you don't do the plus grid divided by 2, the circles won't be right in the middle of that grid mark. The expanded grid mark, it will be placed wherever the X and Y meet on the grid itself, and so it will be a little bit off and won't line up with the apples as it's going across the field. So I add that grid size divided by 2 to account for the circle being drawn with a radius. Then again, with the radius is at grid size divided by 2 minus 1, and that's just to give it that circle within the grid square that it's built. When I built this out, I built it as squares rather than circles, and you could clearly see where the snake was on the grid. But again, with the marker as a circle rather than a square, you kind of have to account for the circle in the grid mark. And then I'm just setting the circle's color to blue. Now again, this could be any color. I could even make it purple if I wanted to kind of sort of match the snake head, but I wanted some delineation between the head and the tail. So again, the head is purple, the tail is blue. It looks kind of weird for a snake, but again, this is just a game. Then I set up its movements. Now, there's going to be a little bit of repetition between the movements and growth because they use they use the exact same methods to move the snake. However, to grow the snake, again, we have to make sure that sometimes we grow 2 instead of 1. So I actually had to create the grow method separately. Prior to this, just testing it out, every time the snake hit an apple, I grew 1. So I could actually make this shift only if the snake wasn't growing. I had the growing method set up as a Boolean. If the snake was growing, then it wouldn't shift. If it wasn't, it would. So you could get the growth by 1. However, when I'm adding 2 new tail pieces, I actually have to add them into the array and then shift off the tail when I'm moving, and you get to see that growth. Finally, I forgot to remove the reassignment of the Boolean after I added that, but there you go. Then when we were going through the movements in the actual game, we had a method called can change direction to. Now, again, when the snake's moving, it can't turn upon itself. So if I'm going left, I can't immediately click right because that would cause a collision. If I'm going up, I can't click down, and vice versa. So I had to create can it change direction. So when traveling up, I cannot click new direction down. When traveling down, not up, left, not right, right, not left. Then I needed a way to detect collision, so I am going to find the x value of the head, and that's just whatever the head is at 0. And that head is a private method, and it tells me the last position array of the position array. And again, define y, just gives me that y value. Again, grow is the method that we're using to add tail pieces to the end. We talked about that in the movement method, why I have two very, very similar methods. The one is just because I have to be able to add that extra tail piece when I'm touching the larger apple. Finally, I have collision. It basically just checks whether or not there's a collision. So the first way I'm doing this is if there's a collision with the snake, then when I check the positions array for the separate positions, if I use the unique method on arrays, it will give me it will only give me the values within that array that are different or differing. So if I use the unique and test it against the actual length of the position array, then what's going to happen is that unique length is going to be less, so a collision has occurred. Or I have to check for wall collisions, and this is where if the snake head is at 0 or the grid height, or the snake Y is at 0 or the grid width, then it's going to be a collision as well. And let me go ahead and clean up this call here real fast. This should be called positions, not position, because it's an array of all the positions in the snake class. All right, let's see. I think that just about covers everything. I did make a change, so I'm just running through real fast to make sure that I didn't change anything in the game class. So after that, that's pretty much it. Again, if there are any questions, please feel free to ask them in the forums on Topcoder, and I will answer them as soon as possible. Thank you.